This is a more realistic version of that first example we looked at. Suppose 2,000 E. coli bacteria are in someone's bladder at time t equals 0. In other words, this person has a bladder infection. This aggressive form of the bacteria reproduces according to the function P of t equals 2,000 times 2 to the t over 10. So the exponent is t divided by 10. Where P of t stands for the number of bacteria at time t, graph this function. Okay, so while we're graphing this, think about what your inputs should be so that just to make your life easy. Now, does it make sense to graph negative values here? It really doesn't. So what I could do is just graph kind of an L shape for the first quadrant, right? Just a positive x and y axes. I don't really need anything else here. And now, just to make your life easy, so the inputs are represented by t, the outputs by P of t. What sort of inputs, t values, would be good to plot here to make life easy? 0 would be good. But I think if you made t1, then you'd have 2 to the 1/10. That really means the 10th root of 2, remember. Is that all that easy to work with? No. So how about instead of 1, how about we plug in 10? Yeah. And the one thing I didn't put in here is t is in minutes, not hours. Okay? So after 10 minutes, we can figure out how many bacteria will be in the system. Okay. So what would another value be? 20. Yeah, so now you're getting it, right? Anything that's divisible by 10 is going to be easy enough to work with, right? And then let's do, 30 and call it a day. So what happens when I plug in 0? Well, we were already kind of given that answer, right? At time t equals 0, what's 2 to the 0 over 10? Same as 2 to the 0, which is 1, and we were told that there's 2,000 bacteria at time 0. So we kind of already knew that. Okay, what does this little equation become? Let me slide over here. What does this output become when we plug in, say, 10? So P of 10 is 2,000 times 2. What does the exponent become when you plug 10 in for t? 1. That's why it's easy to work with, right? I can do 2,000 times 2 in my head. 4,000, right? Okay, after 20 minutes, it becomes 2,000 times 2 to the, when you plug in 20 in there, you get 2, right? Okay, so what is that? You got to do the exponent first, which is 4. 2 squared is 4 times 2,000? 8,000. And then finally, when you plug in 30, what do you get? 2,000 times 2 to the third power, right? And that's, okay, so that's going to be what? 8, 2 to the third is 8 times 2,000? So 16,000. So they're reproducing at a good clip there, right? Now, are you going to want to go by ones on the x-axis or y-axis here? No, in fact, you're going to have to scale both the x and y-axes differently, right? Okay. Probably should have called that t and P of t, right? And then what would be a good scale to go by on what would be the t-axis? No, for the inputs, just kind of what we went by in the table, right? Yeah, so how about 10, 20, and maybe I should space them out a little bit more. 10, 20, 30. Okay, and then what about on the P of t axis, the vertical axis? Well, yeah, but the problem is it goes up so quick. If you got to think about the last output, 16,000. you're going to have a lot of scale marks, I'm saying, if you do that. So how about something, maybe 4,000? That might be a little better. I mean, it really is up to you. 2,000 wouldn't be terrible, because then you'd have 8 scale marks, right? That wouldn't be too bad. But I think if we went by 4,000, it'll be a little more economical. So if we go by 4,000, you better label it if you're not going by ones, right? 4,000, and then the next one is 8,000. And then what's the next one? 12, and then 16. That I think, to me, that looks like a nice way to scale it. And then it's just a matter of plotting points, right? So 0, 2,000, right halfway up, right? And then 10, 4,000. 20, 8,000. That's 20, 8,000. And 30, 16,000. And so you're not going to go to the left of the vertical axis here. That doesn't make sense to make the input negative. Connect the dots in a nice smooth curve, and you get that typical exponential curve increase where it can be a fairly sharp increase. So there you go.